Hydropower is generated by using the kinetic energy of moving water to spin a turbine generator system. The equation for the amount of power to be generated is as follows, with Q being volumetric flow rate, H being head or net height difference between water intake in the turbine, and eta is the overall efficiency of all components. For simplicity, rho Q can be replaced by mass flow rate M, which is in kilograms per second or liters per second, since 1 liter of water is equal to 1 kilogram. The two main factors that affect overall power generation are flow rate and head. More water is equal to more power. Hydroelectric power is considered to be one of the most useful energy sources because it doesn't require fuel as it would be described in a typical sense. Water is the fuel, and its abundance helps lower the cost of generating power. In fact, hydropower has the lowest cost per kilowatt hour of any renewable or non-renewable energy source. Hydropower produces zero emissions, disregarding those released during construction. Other environmental impacts vary based on the type of power generation. A hydroelectric dam can have very significant effects on the existing environment, seeing as how it usually leads to the creation of a lake, but a river runoff station isn't as impactful. The trade-off, however, is power production and reliability. A hydroelectric dam is always going to have water to spin the turbines, but a river or other existing flowing body of water-based system is dependent on the behavior of said body of water. Another benefit of hydropower is its efficiency. A modern turbine can convert around 90 to 95% of the available energy from the water into electricity. It completely outclasses even the most sophisticated fossil fuel plants, which are at best only around 50% efficient. Furthermore, any inefficiency present has essentially no negative impact. Since the fuel, water, is acquired at no cost, losing out on power doesn't make the system more expensive. Additionally, any unharnessed energy is retained by the water. It doesn't manifest as unspent nuclear fuel or as pollution from a fossil fuel plant. And it's not like anything happens to the water that is used. Most of its kinetic energy is transferred into the turbine, the only effect of which is the water slowing down. Then it continues on back into the water cycle virtually unaffected. While hydropower is undoubtedly a very useful and practical form of generating electricity, it isn't without its caveats. Overhead costs are high, making it difficult to sell. Smaller, more affordable systems aren't always reliable since they are based off natural water sources which are subject to change over time. Furthermore, hydroelectric dams have a notable risk associated with them. If they fail, they can potentially cause vast amounts of damage. Additionally, the two main requirements for hydropower, flowing water and significant elevation difference, aren't found together everywhere. Places that are flat, like Kansas, can't really benefit from hydropower. Overall, however, the benefits of hydropower far outweigh the risks, and it will most likely be an expanding source of electricity in the future.